All right, take two. Let's try this again. Had a couple minor issues on the example that we did in class, and I thought what I would do is just post a real quick video highlighting everything that should be right and just go through it step by step, just to make sure that there's no confusion on the steps. The steps are all correct. There was just some signs issues that can throw things for a loop. So let me go back to the notebook. So let me go through the problem step by step and make sure that everybody's clear on how you should go about doing this. So first off, the process, the distance vectors were correct. The unit vectors were correct, although this term here, the 2/3 k, should have been negative. For some reason, I had that written as positive. But if you look, the BD vector up top, if you look right here, that's a negative 8k. So this should be negative 2/3 k down here. And for some reason, it was written as positive. So that might be an error in your notes. And then right here, just to make sure this is clear, I think we went back and forth on this one. That is the correct vector. The 2/7 or the k component should be positive. Okay. Other than that, there really weren't any issues. I went through all the numbers again. There really weren't any issues going forward. The force vectors were correct. The position vectors were correct in their construction. And if you went through the cross products, the weight of the sign, that one was correct. The tension in cable BD was correct. I think the issue came from this one right here, because this term should be positive. So that means in that cross product, that 2/7 should be positive. So what happened is this term came out negative. And so I think not only did that throw some numbers later on, but this was a problem that matched an example in the book. And when I did the 2x2 solution, I was like, something isn't right here. So I thought I'd go through step by step. And I think this right here, this is what caused the overall issue. Now, what you do is you still go through the process like you normally do. I lined up the vectors right here and lined up all the I components, which there weren't any, lined up all the J components, and lined up all the K components. Keep in mind that I kept track of that negative here, and you can see it right there. And what we got is two equations, two unknowns. And just in case, there's a chance I might have gone through that kind of quickly during the in-class example. I want to go through that in a little bit more detail. So solution via Casio. So to solve this via the Casio, this is a two equations, two unknown system. So you go mode, and then you do mode 5, which is the equation solver mode. And then you do option 1, which is 2x2. And this is 2x2 because there's two equations, two unknowns. And then you'll enter a table of numbers. And the table of numbers that you enter is the following. So, what the Casio is asking for is it's asking for this equation, this box of equations right here, but it's asking for them in matrix form. And so what I do is I just enter the coefficients and the constants as they're written. So minus 12/7, 16/3, 0, 18/7, 8/3, 10/80. Okay. Now, what the Casio interprets this as is minus 12/7, 18/7, 16/3, 8/3. It interprets your variables as x and y. So if you remember from matrix multiplication, the x term, that's going to be the first variable that shows up in these equations up here. So the TEC, and this is TBD equals 0, 10, 80. Okay. So when you solve this out, whenever you write your terms in the Casio, you have to make sure that your equations are written in order. And what I mean by in order, look at the box, look at the way I have the equations written. Notice how I have a term times TEC plus a term times TBD, and I have it in the same order on the lower equation. So it's always TEC first and then TBD second. You could swap it. You could do TBD first and TEC second, just as long as you are consistent when you program this in your Casio. Okay, so let's open the Casio. So here's the Casio. Go to mode, 5 for equation, 1 for 2x2, and then minus 12 divided by 7. Or wait, oh, I pressed the AC instead of, sorry, so minus 12 divided by 7, and then press the equals button. 16 divided by 3, press the equals button. 0 equals 18 over 7 equals 8 over 3 equals 1080 equals. Okay, and when it's all said and done, you should get X is 315 and Y is 405 over 4. Yeah, okay, those are the correct answers. So the Casio, let me minimize this. The Casio yields X is 315, Y is 405 divided by 4. This right here, this is the means to solve this via the Casio. Let me erase some of these arrows. That way you can access this later in your notebook. Like so, you don't have to use the Casio. You can do it by hand if you'd like. I just find it to be a lot easier. Come on. Okay. So therefore, the tension in BD, in this case was Y, was 405 over 4. Or if you want to write that, you can say it's 101.25 pounds. And then the tension in EC is 315 pounds. Now, if all you were trying to do was find the tension, done. But that's not all that there is to it with this problem, because we also need to determine the reaction at A. Okay, so in order to determine the reaction at A, we're going to now look at force equilibrium. And so what that means is that means sum of forces. Okay, so summing forces and setting them equal to 0, you sort of do it the same way, and just instead of summing the cross products, you're just summing the original forces. So there were 4 forces on this problem, but before I line them up, one of the things I want to do is I want to look at the force vectors for the cables. Now let's take cable TBD start. Remember, we write that as the magnitude of that cable times the unit vector in the direction. Well, now I have that figured out because I know that the magnitude is 101.25. And I know the vector because I have that here. The unit vector for BD is minus 2/3 I plus 1/3 J minus 2/3 K. Let's check my signs on that. Okay, that's correct. All right. So if I chug this out, what I get is I get negative 67.5 I plus 33.75 J, and then I get minus 67.5 K. And I'm going to do the same thing with the other one. So T EC is T EC times lambda EC. And so that one, the magnitude was 315. And then the unit vector is, let me get the signs right, minus 6/7 I plus 3/7 J plus 2/7 K. And so that, when you chug that out, you get minus 270i. I'll put a decimal on that one above it so you can clear. Plus 135j, and then plus 90k. Okay, and the signs are correct. Good deal. Okay, so now I've got those those two vectors, but there are two more. First off, there's the weight vector. The weight vector, if you remember, was 0i, it was 270j, and then it was 0k. But that was a negative term, so maybe I'll write it like that. And then the other vector is the A vector. Let me write that a little smaller. And that's AXI plus AYJ plus AZK. And what you'll find is that this is actually, at least with a problem like this is the easiest one to solve, because there's, if we look at what's remaining, if we go back to the very, very beginning, if you look at the beginning, there were 5 unknowns. We already solved for the 2 tensile components of the cables. So we only have 1 unknown in the X direction, 1 unknown in the Y direction, 1 unknown in the Z direction remaining. So this is actually pretty simple because, I keep drawing that line, but really what I ought to do is just do this. I ought to just say, if I look at all those I components, that's the sum of the forces in the X direction. Just set that equal to 0. Sum of the forces in the Y component. Set those components equal to 0. Sum of the forces in the Z component equal to 0. And it's really easy. Let me show you. So let's take each of these one at a time. Let me make my pen. So if I sum forces in the X direction, I'm going to get AX, and then what? Okay, I'm going to get minus 67.5, and I'm going to get minus 270 equals 0, right? Because I'm just basically summing all of those terms, all the terms times I, right? And so I look at this and I see, okay, solve for AX. That's pretty easy. Just add everything over to the other side. And so that ends up being 337.5, and that's pounds. And then if I sum forces in the Y direction, I just do the same thing. And again, you're going to see this is kind of boring because, it follows through pretty easily. AY, and then maybe plus 33.75 plus 135 minus 270 equals 0. I get AY is get 101.25, 101.25. And then lastly, summing forces in the Z direction. So let me scroll up a bit. Okay, so AZ minus 67.5 plus 90 plus 0 equals 0. This term, I believe, comes out negative. Yep, that's going to be minus 22.5. And that's it. So we have AX is 337.5 pounds. We have AY is 101.25 pounds. AZ is minus 22.5 pounds. And then there's the 2 unknowns for the cables. There was the tension in cable BD, which was 101.25 pounds, and then the tension in cable EC, which was 315. And that is the answer. And this is an example that's also documented in the textbook. It's sample problem 4.8. And you'll see, I like going through this in class. I don't want to say they skip steps, but they definitely make us they they are much more succinct than I am because they're skipping over a lot of things that they had covered in earlier parts of the book. I really do like this problem because we go through step by step. I just wish wish I hadn't made all those mistakes, but it happens. What we're gonna do on Friday is we'll do another problem that's kind of similar, just to go through it step by step and make sure that we don't lose any issues there. That's all I have, everybody. I will post this as soon as it processes.